Alright, here's our last lesson of chapter 10. This is on what's called geometric probability. So the first thing I need you to understand is what probability means in general. Like, for instance, if I asked you for the probability of when you flip a coin, you get tails. To find probability, it's just the number of favorable outcomes over the total number of outcomes. So when I'm flipping a coin, there's only one chance of getting tails out of two possible outcomes, so it would be 1/2. Or what if I asked you when you rolled a dice, what's the probability of getting an even number? So there's 6 sides, so that tells me the possible outcomes, that's the total number that always goes on the bottom. And then how many of them are even, how many are favorable outcomes? That'd be 3, and I gave you another instance where it's 1/2. But the idea is that what I really need you to focus in on is that the total number of possible outcomes goes on the bottom. Okay? So we're going to look at a couple different geometric scenarios with probability. This first one is probability of it landing on a segment. So if you imagine a random point K that we don't have on the segment right now, what is the probability that it lands on this section? To figure that out, you would need to know how long that section is over, again, the key is over the total, it's always over the total length. So let's look at an example of this. So we want to know if a point is chosen at random on AK, what's the probability that it lands on the given segment? So the first segment we need to worry about is CH, is we would need to know it's all about length. You need to look and see how long CH is. You can do that one of two ways. You could just subtract the end number minus the start number and get 5. Or you can count hops. This is 1, 2, 3, 4, 5 hops. So if you're more visual, you could do it that way. But that would be the top number of our fraction. And then the bottom number needs to be how long the whole segment is. That goes from 0 to 10. So that has a length of 10. So 10 would go on the bottom here. All fractions are going to be reduced. So we're going to divide by 5, and we get the probability is 1/2. And we're going to leave this section as fractions. Alright, then let's look at the next one, DJ. Again, I'm going from D out to J. You can either subtract those numbers or count how many hops that is, but that should be 6. Out of the bottom number is going to stay 10. And then we're going to divide those by 2 each, and we get 3/5 as our probability. We have a 3 out of 5 chance of landing on that segment. Alright, EI. To go from E to I, that's from 4 to 8, so that has a distance of 4 over, still 10 on the bottom because the total goes on the bottom, and then we're going to reduce. Divide by 2, we get 2/5. And then the last one, AK, is actually the whole thing. The whole thing measures 10 out of 10. We get a probability of 1, which is the same thing as saying there's a 100% chance that it's going to land somewhere on AK if it has to be on AK. Alright, then these are word problems where I'm actually going to encourage you to draw a segment out to help you figure this out. So it says, at a given bus stop, a city bus stops every 16 minutes. If a student arrives at his bus stop at a random time, what is the probability that we will have to wait more than 4 minutes for the bus? So we're going to start by drawing out a segment here, with the total being we're going from 0 to 16 minutes. That's how much time passes for the bus to show up. And then our sweet spot that we're talking about is 4 minutes. We know in here this section is less than 4 minutes, and in here this section is when it's more than 4 minutes. And we want to know the probability that he's going to have to wait more than 4 minutes. So that's this whole section. So you just have to figure out how long that section is. Just some simple subtraction there. 16 minus 4 tells me that section is 12. And now to find the probability, it's 12 over the total, which was 16. And then we're just going to reduce that. That we can divide by 4. And we get 3/4. Now let's pause for a minute and talk about how you could change that to a percent on your calculator. I'm going to write both of those for these problems. So to do that on your calculator, you would do 3 divided by 4, And then if you multiply by 100, it'll change it to the percent. This would be 75%. All right, let's look at the next one. So the next one, we're talking about a traffic light. It says that the traffic light is green for 40 seconds. It is yellow for 5 seconds. And then it's red for 30 seconds. We want to know if you reach the intersection at a random time, what is the probability that the light is red? So that tells me my top number is going to be 30, because that's how long it's red for. But then be careful with this one for the bottom number. You need to know the total, which they did not give you. You have to find that yourself by adding these together. The total is 75. So we do 30 over 75, which I can divide those both by 5. That's 6 over 15, and then I can divide again. That's going to be divide by 3, 2 over 5. Or if you change that to a percent on your calculator, divide 2 divided by 5 times 100, that's 40%. So you have a 40% chance that the light is going to be red. It's red 40% of the time. Alright, the last one says your friend is supposed to call you between 3 p.m. and 4 p.m. At 3:20 you realize your cell phone is off and you immediately turn it on. What is the probability that you missed, that's an important word, missed your friend's phone call? So we're going to draw this as a segment as well. This starts at 3 p.m. and ends at 4 p.m. And 3:20 is in here. So we know that it was off during this time, and this time it was on. We want to know the probability that you missed your friend's phone call. So you need to think about which of those sections represent the time where you could have missed it. We could have missed it when it was here, when it was off. So we need to know how big that section is. That's 20 minutes. Out of the total would be how long this whole section is. That whole section is 1 hour, but we need to put that in the same unit, so that would be 60 minutes. So it'd be 20 over 60. I can divide those both by 10. That's 2 over 6, and then divide those both by 2, that's 1/3. Or if you change it to a percent, 33.3%. Alright, then the bigger problems we're looking at today involve actually using the area formulas from this chapter. If I want to know the probability that a point would land inside of region M here, I would actually need to know its area. So we have to do the area of M, but then the bottom of every probability problem is supposed to be the total. So for the total, I would need to know the area of this whole bigger shape here. So there's always going to be two things that you have to find the area of in the picture, and we're going to make sure that we write it out very clearly what we're trying to find. So the idea is you need the area of the shaded over the area of the total. So when we go to do these, you're going to have to figure out each of those things. What's the shaded part, what's the total part, and we're going to write it out each time. So if you look at number 1, the first thing I need to know is the area of the shaded part. The shaded part right now is a circle. So then I need to find the area of that circle. Area formula is pi r squared. So that's going to be pi times the radius here would be 4, because all the way across is 8. So it's going to be pi times 4 squared, which is 16 pi. And we're always going to change these to decimals for this problem, because I know my final answer is going to also have a decimal in it. So go ahead and change it to a decimal right away on your calculator. This is 50.27. Then the other thing we need to know the area of is we need the area of the total. The total, what we mean by that is what the outside shape is. So the outside shape is a square. So I need to find the area of that square. That's going to be side squared. And then the side, you're going to have to do a little bit of moving, as I can move that 8 down. That's how long that side is. So it's going to be 8 squared, which is 64. So now to find the probability I have to do the area of the shaded divided by the area of the total. So the probability is going to be the shaded part 50.27 divided by 64. You're going to divide that on your calculator and multiply by 100. All of these will write as a percent. So that should be 78.5%. Alright, let's look at another one. In number 2, again, the first thing we need to find the area of is the shaded. So the shaded part in number 2 is just a triangle. So I'm going to have to use its formula, 1/2 base times height. It's going to be 1/2 of 12 times 9, which is going to give me an area of 54. And then I have to find the area of the total. So to find the area of the total is a rectangle. Again, the total is that outside shape. That outside shape is this whole rectangle here. So then for the rectangle, I'm going to have to do length times width. Just be careful, the one side is 12, the other side, make sure you're thinking about what the whole side would be. That whole side's going to be 20, so it's 12 times 20, which is 240. And then to find the probability, it's the shaded divided by the total. So that's 54 divided by 240. You're going to divide that on your calculator, multiply by 100, and then you're going to round to the nearest tenth. And this comes out to 22.5% on the calculator. Okay? The next couple get a little bit more challenging, so I need you to really think through the process that we're going through. So number 3, again, the first thing you need to know the area of is you need to know the area of the shaded. I think I was doing that in red before. So it's the area of the shaded. Look at what's shaded here in this picture. This is the part that's shaded right now. Think about what we call that, because that'll help you remember what formula to use there. This is called a sector. So the formula for a sector is the measure of the arc over 360, and then we're trying to find the area, so it's going to be pi times 3 squared. And then I'm going to type that in my calculator, 80 divided by 360 times 3 squared. I get 2 pi, which I'm going to change to a decimal right away. That's 6.28. If you can give 2 decimal places when you're rounding the ones with pi's off, that would be great. And then the next thing we need to know the area of, it's always 2 things, the shaded, and then the area of the total. The total shape, the whole shape, is a circle. So now we'll find the area of the whole circle by doing pi r squared, which is 9 pi. I'm going to change that to a decimal. I get 28.27. And then I've got to think about what I need to do to find my probability. Probability is shaded over total. So I'm just going to divide those and multiply by 100 on my calculator. And I get 22.2%. Alright, number 4. These are the ones that are a little bit more challenging, because if you look at what's shaded here in number 4, it's not actually a shape that's shaded. So the first thing you have to think through is how I can find the area of that shaded part. We have to actually go back to what we were doing earlier this chapter. To find the shaded part, I have to look at 2 separate shapes. There's 2 shapes I'm looking at there. There's a big square and a little square. So to find the shaded part, I'm going to have to do the big square minus the little square. Since the little square is not shaded, I want to take it away. But I have to do all that math first just to find the shaded area here. So the area of the big square would be 5 squared, which is 25. The area of the small square is going to be 3 squared, which is 9. So then that's 25 minus 9 gives me that the shaded part has an area of 16. Then I need the area of the total. the total shape is the big square, which actually we've already found. We know that that area is going to be 25. So then to find the probability, I'm doing the area of the shaded part, which was 16, divided by 25. And I'm just going to put that in my calculator and multiply by 100, and it comes out to 64%. Okay? There is one like this on the class kick for you to try with a circle, so please make sure you're thinking about how to get that shaded part when it's a ring like this one is. This kind of looks like a ring, it's kind of a square ring, but if it's a ring type problem, you're going to have to subtract to find the shaded part first. Then you can set up your fraction doing shaded over total. Okay, so there's 3 problems for you guys to try on class kick. Please do those. Please message me on Hangouts if you have any questions. And then there's going to be a homework assignment tonight, and we're going to do an in-class assignment tomorrow just to make sure you've got a good handle on this probability section.